Okay, cool. All right, so let's start. Start out with a little joke here. You guys can read. I guess you guys can read it later.
Wait, no.
Automotive technology has kept pace with the computer technology over the past few decades. What? Those eight. 32. That would be 1,000 miles per hour.
So funny. Oh, I didn't come up with that one. I copied it.
I said, where did he come up with
Oh. All right. So in all these books over here, and most of the time when you're learning about arrays and tutorials and things, they always start with this type of problem. Like, why would you need an array? So here's an example of a problem where you would need an array. Let's say you need to write code to record the weights of the contestants of the Biggest Loser game show. You guys ever see that game show? If you had to, let's say you're in charge of writing the code for that. And you have to make 10 variables to store your contestants' data. So you store your contestants' data in contestant 1, contestant 2, 3, 4, all the way to 10. And let's say that you wanted to write a method that takes in all the contestants and maybe prints out their weights to, you know, a screen. I don't know. Changes all their weights. How many parameters would you have to have in that method if you wrote your variables like this?
as many as there are.
Right, you'd have to have 10 parameters for all your contestant variables sending into this method.
You can have up to 255.
Yeah, you can have 255. That wouldn't be that bad. What if you had to change the weights of these contestants? You'd have to copy and paste these variables. You're maintaining 10 different variables, and you have to keep track of these 10 different variables. Maybe you could do it. But what if your boss comes to you and said, hey, I want you to change that program to record all the contestants that try out for the show. So there's 1,000 people. So you just copy and paste your code 10 times, or was it 100 times? Now you have 1,000 variables. What if you want to send that into a method? All of a sudden it doesn't work anymore. What if you want to change their weights? You're changing 1,000 different variables. Just to declare them, if you declared one per line, that's 1,000 lines of code. It starts becoming unmanageable really fast. So large amounts of data, and we live in a world of large amounts of data. Large amounts of data become very hard to manage in a program without some kind of data structure. Okay, so you need some way to encapsulate and put this data into one variable so that all you have to do is manage this one variable with all of your data inside of it, instead of having 1,000 separate variables. We're going to wrap them up all into one, and it's called a data structure, and it's called an array. All right? Can someone get the door for me? I start getting distracted. All right. So an array is what we study in here. An array is the most basic type of data structure. It's built into a lot of different programming languages. Okay, I think all programming languages that I know of support an array. Okay. An array is considered an object. And I know we haven't studied object-oriented design in here, but an object is something that has data associated with it and methods associated with that could work on that data. And later on when you learn object-oriented design, they make even more sense. But just note that arrays are treated as objects in Java. All right? They're used to store a possibly large collection of data. Okay, like I said, we live in a world of data. Lots and lots and lots of data. So, you know, data analysis is actually a huge field right now. So if you start getting into data analysis, you can make a ton of money. You can invent new things. Right? All right. All the data stored in the array must be of the same type. So the rule is when you make an array, all of your data must be of the same type, such as they all have to be doubles, or they all have to be integers, or they all have to be characters. And when you get into object-oriented design, you can actually have an array of your objects. So if you made a dog object, then you can make an array of dogs. an array of employees. But they all have to be of the same type. An array object has a small number of these predefined methods that are associated with it, so some things your array can do automatically for you. So it comes with some functionality. And even though an array is an object in Java, it can be convenient to think of it as just a collection of variables all of the same type. All right, so how do you write an array in Java? This is how you create an array in Java. You can write it in 1 line or 2 lines. More acceptable is the 1-line method, but remember that you can declare it. This is called your declaration. And this is called your instantiation.
Could you repeat that again?
Actually, this one, okay, so this is called your declaration, and this is called your instantiation. And he is an object, so that is an instantiation. Or you can put your declaration and your instantiation all in 1 line, which is easier, I think, and more people do it that way. Okay? So what this is telling the computer is make a reference to an array here. So the only thing we added was these 2 square brackets. The 2 square brackets say, hey, I'm a reference, I am an array. And then over here we use the new operator. We put the type it is, so this type and this type match, right? We use the square brackets again, and we put how big we want our array. So you have to declare its size. You can't say, I just want an array of 0. Well, you could say 0 size. You could put a 0 in there.
Or leave it blank, right?
You can't leave it blank. You have to put a size in there. Okay?
And the main method is has like those 2 brackets.
Yes, that's an array. Very good, yes. So string bracket bracket args in your main method declaration, that is declaring an array. Very observant, good, yes. Okay, so that is an array. And in your main, that string bracket bracket args is when you're compiling it, you can actually give your program some information when it starts. So that's what that's referring to. We just haven't written programs like that, but we can. It's not that hard. Okay. All right, some terminology. You can name your array anything you want. Okay, but we follow the conventions of variables, meaning that we use lowercase letters when naming our arrays. You don't start with a number. You don't use weird characters. You usually name it something that it is. So if you were holding temperatures, we name the array temperature. Note that in Java, a lot of times we use singular nouns, not plural nouns when naming arrays. So you name it temperature, not temperatures. You'll see some people don't follow that rule. About half and half follow the rule. But it just makes it more readable when you're reading your code to have it a singular noun. Okay? All right. So that's your array name. What goes in the square brackets when you're accessing something in your array? So here I'm accessing a variable in my array. And what goes in the square brackets when you're accessing in there is called your index. Okay? So that'll be your index. The whole thing together, when you're indexing in your array, is called an indexed element. A lot of times they call it an element. Sometimes they call it indexed variable. I like to use the word element. Most of the books up here use the word element in your array, or element. Okay? Or sometimes they'll say indexed element. All right? And then what you put inside of your array is called the value of your array. So value of the indexed element, value of the indexed variable kind of mean the same thing. But that'll be what's stored in that array. It's called your value. Okay, so indexed variable and then value. So an array can help us with the problem of declaring all these variables to hold the contestants of our Biggest Loser. So instead of writing 1,000 or 10 different variables, we can write it in 1 line of code. 1 line of code, it creates 10 doubles for us in memory, and now we can use it to hold all of our weights. So much easier than 10 different lines of code. If we wanted 1,000 variables, we would just change this to 1,000, and it's still 1 line of code, and not 1,000 lines of code. Very convenient. Arrays are very, very convenient. Make programming much easier. Now, it's just like declaring these 10 variables. So when I'm indexing in my array, It's as if I created these 10 variables. So writing this line of code is like I created these 10 variables. And these are my 10 variables. And these are the names of my 10 variables I created. So contestant index 0, contestant index 1, all the way to contestant index 9. So I have an array of size 10, but my indices go 0 through 9. And that's important. So my length is 10, and my indexed variables are 0 through 9. And almost all programming languages follow this convention that you start at 0 and you do not start at 1 when you index inside of an array. And it makes sense. How you allocate RAM and how you're doing your offset, it makes sense that your first index will be 0. Because it's keeping track of the memory location of the first guy and then adding that indexed offset to figure out where the other guys are, the other variables in your array. Okay? So almost all programming languages will start with 0, except for Maple, who starts at 1, which is really not. Actually, a couple other ones start at 1, but 99% of programming language will start at index 0 and go to that length minus 1. Okay, so it's always 0 to length minus 1.
You guys use Maple on Street?
Yeah, but we're gonna use MATLAB next time around next spring. We bought MATLAB.
I'll be in there.
It's being installed. So, all right. So these variables can be used just like any other type of variable. So they can use just like any other double, such as if I wanted to put 320 inside of that variable, I could write something like this. If I wanted to use that variable inside of an equation, I could write it like that. So they're used just like you use other variables. They just have the square brackets there and the index number. Okay, so don't think that they're different than another type of double. They're just a regular old double. Okay, and you can just use them. You can print line them. You can send them to a method. They can equal something back from a method. Anything a variable can do. Okay. The expression in the square brackets can be any term that evaluates to an integer. So as long as this is an integer, we're okay. You can even put a variable name that was an int in there. You can even do keyboard.nextInt because it gives you back an int. Okay, so anything that evaluates to an integer can go in those square brackets. All right. So an array is just an easy way to store the same kind of data. It can hold data of any primitive type. It can also be used to store many objects. And a lot of times, well, almost all times, in all these books, they draw a picture that looks like this to represent an array. So, in fact, I like to use Excel. I can use my stacks. So here I was representing an array right here. Actually, I have my array one. There we go. Here's a nice array. So I used to draw them on the board, but I get kind of messy. So I started using Excel to represent our arrays. And Excel works great because, you know, arrays can be thought of as, you know, little boxes. And so these little boxes can represent an array. All right, when I represent an array like this, these are its index values. So what's the length of my array? How many elements are in my array? 8, right? And my indices go 0 through 7. Okay. So when you start getting into computers and data structures and start getting more into this, you have to start visualizing in your head what is going on with this data structure. Because they have different algorithms and you have to have this visual. So when you visualize an array, I want you to visualize something that looks like this. Okay? And this is a good visual because when you make an array inside of your RAM, inside of your main memory, inside of your computer, It allocates memory locations that are indeed next to each other. So if you say you need an array of 80 doubles, how big is a double? How big is one double? How much memory? Do you guys remember?
It's either 4, 16, or 32.
It's 8 bytes of data. 8 bytes. So 8 bytes is 64 bits. Okay, but you can, so it would do 8 bytes times 80 doubles. So that would be 640 bytes that it would allocate. So it would find congruent, or it would find those many bytes. Was it 640 bytes next to each other in RAM that's available? So they're consecutive memory locations. They're memory locations that are next to each other in RAM. It would find that and it would allocate that memory for your array. And it would give you back the address of that first memory location. And that's what your array stores. It stores the address of the first memory location and how large it is.
So using like 56 or 58 would be like that whole 640 bytes space.
So this would be 8 bytes, 8 bytes. So if I allocated an array of doubles, let's say this is integers. How big is an integer? 4 bytes. 4 bytes, so that would be 32 bits. Okay. So 4 bytes each. This would be 4 bytes, 4 bytes, 4 bytes, 4 bytes, 4 bytes. So you can, this is an abstract picture. It's good to think abstractly when you're thinking about computers. You can understand lots of algorithms if you can start to visualize abstract pictures. That's why people who play games are actually really good at computers usually, because they can visualize these things in their head. Okay? But that's what you should see when you look at an array. Or when you see an array in code, you should visualize an array that looks like this. So this would be an array that if I declared it, he would be like this. He would say int my array. Actually, I forgot the square brackets right there. They sound like they're having a lot of fun in that class. I don't know what the heck they're doing. Or maybe it's out there. And it would be size 8, so I would declare an 8 in there. So if I were to declare this array that looks like this picture, it would be declared like that. Hopefully you declared that in your head. You started declaring these things. So if I wrote something like this, if I said my array index 6, and I said you equal my array index 4, what would that code do? Right. It would go to index 4, get the number 69, and it would put it inside of index 6. Pretty easy, right? What if I wrote something like this? My array times equal 4. And it would be my array. We have to put the index in here. Index number 2. What would it do then? Actually, that math's kind of hard, right? We'll say times equal 2. It'll be easier to do in our heads. Unless you're really a math person, you can multiply by 4 in your head. So what would it put inside of index 2? 118. Okay, do you see how that's doing stuff like that? What if I wrote something like this, though? My array index 8 equals 9. Yeah, so where would it go? Oh, we get a horrible red error. It's a runtime error. It'll say, oh, there is no index 8. Runtime error, blows up your program, stops working. Note that in C++ and some other lower level languages, they let you do this. This is why C++ is a hacker language. You can access parts of RAM that you probably should not be accessing. But in Java, it's array safe, it's memory safe, and so it will throw you an error when you try to do something like this, an array out of bounds error. I'm sure you guys will even try some array out of bounds errors today. We'll try this in our code. Okay? All right. What if I wrote something like this? Here's a harder one. No. Minus. And can you write something like this? And yes, you can write something like that. What would happen here?
Take away 111.
Yeah. And what would that equal?
So it would make number 7 equal 9.
Right. It would go to index 7 and equal a 9. Okay, so remember that you can have anything in those square brackets that equal an integer. The only rule is that that integer better be an index in your array, otherwise you're going to get an array out of bounds error. That's why I said 111.
So what exactly is the difference between, because this feels like a string. And
Yeah, a string is an array of characters. Very observant, yes. Strings have indices, 0 through string length minus 1. A string is stored as an array of characters. It's encapsulated in a string object, this array of characters, so that we can treat it. We can do things easier, with strings. But before strings, we had to deal with arrays of characters. Okay, that's how you dealt with strings. You had to deal with arrays of characters. So inside of a string is an array of characters.
Wait, okay, so it equals 7, then it takes 7 and puts it in the...
So this equates to 7. So the stuff inside of the square brackets here equates to the number 7. So it's as if number 7 was here.
Right. And then it puts
So it goes array index 7. It puts a 9 in index 7.
Oh, I see.
So it evaluates what's in here first to a 7. And then it goes to index 7 and puts the 9 in there. Okay? Cool. The type of the elements inside of your array is called your base type. So in that example, our base type was type int.
So it does math inside of it? Brackets?
Yeah, you can do anything in the brackets. It can call a function in your brackets. Look, you can have like a
Would it be able to
keyboard.nextInt in your brackets.
So you did like a simple subtraction in there just now? Would it be able to like calculate the wind chill index?
Yeah, you can do the wind chill index as long as it was an index in your array. Okay?
But, like,
So that's the
calculate
only
it,
rule.
Like calculate it though, like 33 minus.
Now you could do a whole giant equation in there if you really wanted to. That's kind of unconventional. People don't really
Right, but I'm
usually
just
do
saying,
that.
it's
But you
possible.
could, as long as it equated to an int that was an index in your array. You could have this huge, giant equation. As long as it equated to an index in your array, it's okay. Okay? All right. Oh. So you can even have an array of type objects. We didn't do object-oriented design in here. You get to do that in programming and methodology too. But you can have an array of anything. Okay? How many elements are in our array above? 3. Good. What are their indices?
0 to 2.
Yeah, 0 to 2. 0, 1, 2. Okay, good. We already said we go to 0 to length minus 1. Remember that your brackets serve 3 purposes, 1 in the declaration, 1 in the instantiation, and then 1 in the indexed variable. So 3 different uses of the square brackets. Okay? All right. Singular array names we already went over. So arrays are objects, so they have this variable that goes along with them. They automatically have this. When you create an array, he gets a length variable automatically. So we can access that length variable by using this dot operator. So you put the name of your array, the dot operator, and the length, and that returns an integer with the length of your array. So that's like a variable you get automatically. All right. When you use arrays, you always use for loops. I always have students, well, I don't like using for loops with arrays, and they write this big long code and they use it like regular variables, and I'm like, no. The beauty of arrays is that you can use it with a for loop. So I make you use it with a for loop in here, okay? So arrays and for loops go hand in hand. There's even a special for loop called a for each loop that is made just for arrays, okay? So this for loop, this is a typical for loop that'll go through every value in the array. So you have an index that starts at 0. Okay, so you make this variable index start at 0. You always go less than length, index plus plus, and that'll iterate. It's called iterating through your array. It goes through every value in your array, which is typically what you want to do with an array. You usually want to do something to everybody. You either want to print out everybody, send all the elements to a function, add 5 to all your elements, multiply your elements times some number. You usually want to do it to every element in your array. So this is how you would write that for loop. This for loop here is setting every value in the temperature array to this number. So it's initializing all the temperature in that array to some number. Okay? Now there's a special loop called a for each loop that's made just for arrays. For each loops are cool. I don't mind if you use the regular for loop or the for each loop. This is how a for each loop works. So you have an array of type integer. So in your for each loop, you have this element that's going to take on the persona of every element in your array in this for loop. So this element becomes every element in your array as it iterates through the for loop. So he's going to be of the same type. So if I had an array of doubles, this would be double here. If I have an array of employees, this would be employee here. If I had an array of characters, this would be char right here. And then you just put the array name after a colon. So you put colon and then your array name. And then in this for loop, it goes through every element in your array. So this for loop and this for loop are doing the same thing. I don't really need the count here. I'm not really sure why I put count in here. Okay. Now we talked about the array index out of bounds error. So if we index outside of our array, we'll get this big fat red error. Here's some common mistakes people make. Remember that it's less than length, not length minus 1. This would be an off by 1 error. Not less than or equal to. Okay. Not starting, so they started at 1 here. You always start at 0. And you always go less than, not greater than. But those are some errors I see all the time. All right, so you can instantiate an array 2 different ways. You can do instantiate the array the way that we saw in the above slides. Or if you know the values in your array, you can actually instantiate an array with these curly brackets like this. So arrays are special that we can instantiate them like this. So what would be the length of my array? If I instantiated him like this, he would be length. So reading.length would equal 3. Good. So it puts the length in there automatically. It sees 3 variables. It makes it the exact size you need. Puts the 3 variables in your array. He's ready to go. So it's this line of code here is doing the same thing that these 3 lines of code are doing, or 4 lines. Okay, so you can condense it and write it in 1 line of code. All right, so if you know the values of your variables, this is a cool, convenient way to make it. Okay. It says uninitialized array elements are set to the default value of the base type. This is debatable. Some people say you should always initialize it anyway, and then some people say, why initialize it? It's already initialized, so I really don't care that it's uninitialized. I mean, they're initialized anyway. I think let the computer do it. But some books will tell you, oh, you should initialize them anyway. In C++, you have to initialize them because it does not initialize them for you. In Java, it means give them some default value. So it means when I'm writing my code like this, when I write this line of code right here, just this line of code, none of these, it puts 0 on all these places. So it automatically fills it with 0. So it goes into memory and puts zeros in all those memory locations for me. Java helps us a lot, and that's one way it helps us. It initializes them all to 0 for me, so they're all 0 already. Why reinitialize them?
That's what the for loop, right?
No, this is just automatically. Right when I write this line of code, it goes into main memory and puts zeros here.
So that it knows there's a space there, right?
Yeah, so it allocates this RAM for me, and then it puts the value 0 in that RAM locations for me. So that when I go and access this guy, they'll automatically have the value 0.
Oh, where's that important?
But it's not.
No, it is. It becomes important later when you're accessing these variables. It can cause some debug errors if you didn't know. You know, in C++, if you assume that they're initialized and then you go and access it and you're treating it like a 0 and it's not really a 0, then you'll have problems. So just remember, in other programming languages it doesn't do this, but Java it does. So I think that's why a lot of authors, when they write these things, they'll say that you have to initialize it yourself, but I don't know. I think if Java does it for me, let it do it for me. That's my philosophy there. All right. So there's 2 ways to print the contestants of your array. Let's look at them. So you can do it with your for loop. So in our example, if we made an array of size 5, we can start at index 0, go to less than array length, index plus plus. This would iterate through our array. And what would it print out? It would print array element 0 is, what would it equal? We just went over that. 0. You got to initialize to 0. We just went over that. Okay. And then it would put array element 0 is 0. Array element 1 is 1. Array element 2 is 2. Array element 3 is 3. Array element 4 is 4. And it would stop at 4. Because remember, we're index 0 through 4. Okay? And it would print 1 on each line. All right. So you can print it that way. And then this would do the same exact thing, but it is printing it with a for each loop. So that code and the other code do the same exact thing. And so in here I say you can use a for each loop or you can use a for loop. I really don't mind. They're used both in real life too, both ways. Okay? Okay, using the equal and equal operators with arrays. Arrays are objects, so you do not want to test if 2 arrays are equal using equal equals operator. All right. And this is good to know. So here's an example of something kind of cool. If I make an integer array, I called it temperature, right? And I initialized him like this, so he's length 4. And he fills those 4 memory locations with those values, 65, 70, 72, 75. So it makes this in memory, right? And then I make another array. I call him temp. And I initialize him to these values. It makes this array in memory. If I say something like temp equals temperature, the way that temperature works is that he's a pointer to where his values are in RAM, right? He's pointing to where they are. Temp is pointing over here. If I say temp equals temperature, now they're pointing to the same location in memory. They are the same array.
What happens to the values in the temp, though?
They get collected by what's called the garbage collector. If no one is pointing to an object in memory, Java has this really convenient feature called a garbage collector. It's one of the reasons Java became very popular. What's called deallocates memory for you automatically. It's called a garbage collector. Okay, so when nothing is pointing to memory locations and you have this memory, and other programming languages, that could be a memory leak. If you don't deallocate it with a line of code, it's a memory leak. But in Java, if no one's pointing to that memory, the garbage collector will come around and go, oh, no one's pointing to that memory, and reclaim that memory. It's called reallocating or reclaiming that memory. Okay? So garbage collectors are in all modern programming languages have some type of garbage collector. C++ doesn't. You have to tell it to release that memory. Okay? That's why a lot of older programs would have memory leaks and problems. Okay. All right.
So it means that you only have one array, not two arrays?
Yeah, if I wrote something like this, and then they're pointing to the same array in memory, you only have one array. So if I put in my code, so using this code here, if I said temp, or temp index 0 equals 5, it would go to temp index 0 and put 5 here. If I go and print out temperature 0, what's it going to print? When I go and print out temperature 0, he's going to be a 5. So there are two names for the same array. If you write code that looks like this, that means point to the same place in memory. Okay? All right. Cool. Let's play around with an array. Let's make a program. We don't necessarily have to make this program here. So let's start up Eclipse. I'll have you guys turn this in today, so I do want you to work along with me. I don't feel like making the Biggest Loser game show again, so we're going to make something different. Let's make something different. You know, these programming problems look a little hard for us. Let's do something easier. Okay. So let's make a new class to test our arrays. So I'm going to make a new project folder for my arrays. You can name it whatever you want. Just remember to name your classes with a capital letter. And I think 90% of us know this by now. We're doing good on this. Remember, always name your class names right here with a capital letter. Starting with a capital. Not all caps. All caps, no. But start with a capital letter. So we could call it testing arrays. I don't mind what you call yours. And you can even check mark public static void main string args. Oh, I was just saying that you could check mark so it writes this for you. And then remember your name at the top. Good habit to get into. All right, so let's make a program that will... Actually, I'll put the input at, sorry. Let's make a program that's going to take in some input from the user, some integers, let's say integers from the user. It'll then take the average and give you the average of those integers, and it'll tell you your max integer and your min integer. That's a good algorithm. Good basic one to do with an array. Okay? So our input is going to be a bunch of integers. entered by the user. And then we'll output a couple of things. We'll output the average, the max, and the min. That's a good basic algorithm. Everyone should know when they leave this class. It's good, yeah, the max value and the min value that the user entered. So the max integer, the highest integer, and then the minimum value integer, the lowest integer. Okay. So in our step 1, we'll ask the user to enter in some numbers. And then we're going to do a for loop. Actually, let's do it in a while loop. We'll ask the user to enter in some integers. Well, the first time around, let's enter in 10 integers. We'll say, not some, we'll enter in 10 integers. So we'll use a for loop the first time around, and then we can modify our code that they can enter in how many integers they want. It's programmed a little bit differently, but we'll do it this way first. It's much easier. So we'll ask the user to enter in 10 integers. Then we're going to have a for loop for I from 0 to 9. Now I could have said from 1 to 10, but I know I'm going to work with an array, so I'm just going to put 0 to 9. That's okay to write stuff like that. Okay, do. Take in the integer and put it in the array. And then what do you need to find the average of something?
That you need to do it.
Hmm?
What do you need?
Yeah, what do you need to find an average? You need all the values, but what do you need? What do you need?
You could use it as a main.
Average equals
Add all the numbers given to the number from
the sum. Yep, add all the numbers. So the sum divided by number of variables. So sum divided by length. So what do we need in our for loop?
We could do a method. We could do a method for that.
Well, we're just focusing on arrays today. We'll do arrays and methods next week. So we need to find the sum. So we can say add to sum this number. In fact, up here I'm going to say make a variable. So make variables. Make sure you start out at 0 when you're doing the sum. So I just added this up here. This is kind of like our initialize our variables. I said make variables. You could say initialize. Okay. I'm writing my algorithm a little bit more informally, but remember, even when you write it informally, you can still write stuff like this. It's a smart idea to write stuff like this. All right. Okay, so add to sum this number. And then outside of my for loop, I would then find the average. So remember, you always find the average after you've summed up all the numbers, so you're always going to do the average outside of your for loop. It doesn't make sense to find the average in the for loop because you don't know your sum yet. You don't know your total. So you always use your for loop. Find the average here, and the average is sum divided by number of variables. And then we want to print out all of our numbers. We'll print out all of our numbers. That seems like a good starter. Now we haven't found the max and the min yet, but this is a good start, so we're just going to program this first. And then we'll add our max and min. So let's just concentrate on finding the average first. And this is the finding the average algorithm. This is a good algorithm. So in this algorithm, we do a for loop. We take the sum of numbers. Outside of the for loop, we divide that sum by the number of variables. And we print out all of our numbers. All right. So let's implement this algorithm. So I'm going to have a double sum equals 0. And now let's implement our array. You can call your array anything you want. I'm going to call it my array of ints. But remember, you can use a smaller name or whatever, but make sure your variable name starts with a lowercase letter. Doesn't start with a number. It follows all the rules of a regular variable. And then I forgot my square brackets. I need my square brackets here. You guys remember this part? The syntax for this part equals... What do we need right here? We need something that has 3 letters. Starts with an N. New. New. New what? Scanner. That would be awesome. That was an object. we usually use the new operator with scanner because it's making an object. So that does tell you that scanner is an object and array is an object.
Yeah.
New int, because he's going to be an array of int. And then what do we put in the square brackets here? 10. Because right now we just wanted to do 10. We're doing something easy now. We're just going to do 10. And that's initializing. Remember, that's called declaring, and actually it's an object, so it's instantiating this object. When you do objects, it's no longer called initialization, it's called instantiation. They use a different word. Yeah, that's our keyword for today. Remember that show, Pee-wee's Playhouse? They always had the word of the day. And everybody would scream. Every time we say instantiation, everybody has to go, woo! Just kidding. Actually, I tried that once. Got a little out of hand. But that's our keyword for today, instantiation, right? All right. So now we need to ask the user to enter in 10 numbers. So we know how to do that. We can say, okay, please enter in 10 integers. We want to specify integers because we have an array of ints. Remember, we don't do error checking in our programs. Oh, dang it, stop pointing at the wall. I hate it when you point at the wall. So part of that video is going to be it pointing at the wall. That's great. I'm getting better, but sometimes I don't check him when he points at the wall. Oh well. All right, so we set up our for loop the same way. Now you could use a for each loop or you can use a regular for loop. I find students find it easier at first just to do a regular for loop with the 3 parts. And it's good to know this way. So it'll be I equals 0, I less than array.length. They're always set up the same way, I plus plus. So this is a typical for loop for an array. I equals 0, I less than length, I plus plus. Okay. They're always set up the same way. It's called iterating through all the elements of your array. Iterating through the array. They call it an iteration. I guess that's another keyword for today. Iterating. All right, so that's going to go through all of my elements in my array. In fact, that loop's going to happen how many times? 10, yes. It's going to go to 0 to length minus 1. So it's going to go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then leave. So that's all the indexes in my array, or indices. All right, now we're going to have to take in some input. So actually we do need a scanner keyboard. So we do need to make a scanner objects. I forgot to instantiate him up here. And you might have to import that scanner package. So I right-clicked and it wrote this import statement for me. And we need him because, we need to get some input from the user. So now we're going to stick all those numbers in our array. So first things first, we'll put that number that they entered in into the array. All right, so here we're treating them just like a regular variable. Note that the first time this loop happens, this I will be 0. The second time it'll be 1. The third time it'll be 2. And it'll go all the way up to 9. So it's going to iterate 10 times, and it's going to put those variables, remember your visual in your head, it's going to put it in those 10 memory locations that we've allocated. Okay, one on each loop. Each loop iteration, it'll put a value into memory. And then we need to add it to our sum, so we'll add this variable to our sum. Note that it's very, very important that we start sum out at 0 so that we can add to him. And we're just following our algorithm, right? So the next step in our algorithm is to find the average. Average equals sum divided by num of variables. So what should I put for my num of variables? How many variables do I have? 10. Now I could write the number 10 right here, but why is that a bad idea? Well, later on, if I want to change my program and make it work for 11 variables, then I have to go through and find the other 10 and put 11 in there. So what's a better way? What's another way that we could write 10 here? What's another way that we could figure out how many variables we have? Jason? Yes, good. Yeah, we could use this length property. And here's another instance where we can use the length property. Oh, and I forgot to declare Mr. Average here. So I'm going to declare him at the top as a double. Because my average most likely will be a double. Meaning something with a decimal, right? So just make sure you declare them somewhere. And voila, now we can print our average. Oh, we want to print all the numbers too. So we'll say the average is average. Now I'm going to have you guys write this part. So I'm not going to write it for you. You guys have to print out all the numbers and figure out how to print out all the numbers. It's pretty easy. Because remember, in our algorithm, we wanted to print out the average and then tell them all their numbers again. So we tell them the average and then we show them all their numbers. Just so they can double check us. So after you get it all in there, make sure you run your code. Give it some easy. Now, when you're testing your code, remember that you should test with some values where you know the average, so you know that things are working correctly, right? So you should always test with some values where you know the answers. So I'm just going to test with 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And the average is 5.5, which is true. And test it again. Now remember, you can separate them with spaces or push enter. So it lets us enter in 10 numbers and then gives us back the average. All right, and then you guys are in charge of printing out all of your numbers. So you guys could, remember you can copy and paste the for loop. The for loop will look exactly the same. Remember, whenever you want to iterate through an array, printing it out, setting the numbers equal to something, this for loop will look exactly the same. So just copy and paste this for loop. You guys are in charge of printing out all those numbers.
Mine is giving me an average of 0, but I'm not typing in.
Oh, okay, so maybe it's int math. If it's giving you an average of 0, make sure that one of these variables, so actually the only variable other than array of ints, which is an int, is sum. If sum is not declared as a double, it'll be an int divided by an int, and it will give you the wrong answer. So make sure sum is a double. Make sure sum is initialized to 0. And that you have plus equal here with no space. And that this is an I. The average is a double. Oh. Okay, so maybe I should come help debug, really. We'll push pause. Yeah, so I remember to, so I should repeat this since I wasn't recording anyway. Dang it. So to find your max, you make a max variable and you make them really small. That's important. If we made them equal to 10,000, nothing's going to be greater than max. And so max wouldn't hold our max value. He'd just hold the number 10,000. So it's important to initialize max to something smaller than all of the input. So you initialize him to something small. And then as you're entering in the numbers in this for loop, as you're entering in those numbers, whatever number you entered, it gets stored in that array, right, at that array location. So you're checking whatever they entered in at the keyboard to see if it's greater than max. And if you're greater than max, then max is going to equal that number. And remember that you have to finish your for loop. So you go through the entire for loop, have them enter in every single number, compare every single number to max. And then outside of that for loop, you can print what max is. And that algorithm, you know, you'll actually use quite a lot in a lot of programs. A lot of times you need to find the maximum. And the algorithm, you know, stays the same. Programming language to programming language, remember your algorithms always stay the same. So you can test them out. Try putting the max in different locations. You know, try putting them at the beginning, try putting them at the end. That would be how you test things, you know. And it did indeed hold and keep my max. All right. So I'm going to have you guys turn this as a class assignment, but before you turn it in, what I want you to do is find the min. So you kind of use the same kind of logic to find your min. Yeah, just reverse it. It's actually super simple. You guys should be able to figure this out. Now, what should min be initialized to?
1,000 million.
Right. Something really big so that something can be smaller than him. It's the opposite of the max. So min should be initialized to something rather large so that something can be smaller than him. So he's like the opposite, right? Right. Very good. Because if you initialize him to like negative 1 million, nothing's going to be smaller than him, and then he'll tell you at the end that your minimum was negative 1 million. Even though you didn't enter that. All right. So your guys' job is to print out all the numbers and print out min. So right here, print out min and print out all your numbers. I'm going to have you guys turn this into Blackboard in a class assignment, which I will make right now. So I'm going to sign off on recording.